you want to estimate what your population is going to be. So if you put your sample mean in there, you already found your sample mean. You don't need an interval. So we're making an inference about the population based on the sample. That's the most important part of this. And did I show you on the calculator yesterday how to do it? Okay, so on the calculator, sometimes when we find the mean and we don't have the margin of error on the calculator, we can work our way backwards and find it. I will go through all the formulas with you and the calculator steps. I like it at least to try the calculator. Some of you I know are not calculator savvy. You're not really comfortable with the calculator. Try harder for this one because this one is so nice on the calculator. I normally I'll do both, but if you get the calculator, steps is so much nicer. Cuts out all the hard work. Now, I put this on your note page. This is important. These are the steps you're going to follow when you construct a confidence interval for a population mean. Knowing the population standard deviation. This is the population standard deviation. We have to know this one. Okay. We want to first verify that we know the population standard deviation. We want to say that the sample is random, and all our samples should hopefully be random. The population has to say normally distributed or n is greater than or equal to 30. Once we've met those conditions, we can go on. If we didn't meet those conditions, we stop. We say, sorry, can't go on. Next thing we do is we find our sample mean. And we said our sample mean is the average. You add them all up, divide by how many there are. Easier for us, we put it in L1. We do a one-var stat. There's no frequency, and X bar is our sample mean. Find your note page. Add some notes to that. The next thing we want to do is we want to keep track of what was your level of confidence. Find your level of confidence. So if my level of confidence is 95%, remember we did this. We did an inverse norm. We need to know this z-score. So we did inverse norm. 1 minus 0.95, watch these parentheses, divide by 2. And that will give us the ZC, the z-score that corresponds to that confidence interval, that confidence level. You're going to get the negative number, you want to make it positive. So if you get negative 1.96, you just use the positive 1.96. You also have a table. And every time you find a different confidence interval, add it to your table. From there, we're ready to find your margin of error. I will give you this formula. It is just the confidence z-score that you just found, your standard deviation from your population, divided by the square root of n. This is because we're using a sample. Remember when we use samples, we divide it by the square root of n? We're using a sample to make an inference about a population. So all we have to do is plug this in, you get your margin of error. Last step, you just put it together. You say x bar plus or minus 8. You can write it as an interval. You can write it as an inequality. And how you interpret this is, we can be 95% confident that our population mean will fall between these two numbers. That's the most important part. How you interpret this. Hey, if you want any bagels, help yourself. So the important part is how we interpret it. Whether you're going to be 90% confident that your population mean will fall between those two numbers, or you're 90%, whatever it happens to be. All right, so we're going to follow one of these through. All right. So we did this part there. So we're going to work on this part. Triad 3 uses the example from Triad 1. And on Triad 1, on page 298, they gave us a sample of workers that had 30 employees. And all they did was ask us for the mean. So we put it in our L1. As a matter of fact, you guys put it in L1. You guys put it in L, well actually no, I have the mean, so it's kind of useless. Alright, so we have the mean. We put it in L1, we find the mean, right? And now we're going to build a confidence interval for this. So we say, okay, step 1. I do know that this was normally distributed, or n was greater than or equal to 30, because my sample was 30. So I qualify there. They did give me my population standard deviation, so I should be okay there. I got my confidence interval. I have to find my ZC. So on a 95% confidence interval, I'm looking at 95% to be in the middle. I want to know what is this z-score. So I do inverse norm, pick up your calcs, go to inverse norm, 1 minus 0.95, use parentheses, divide by 2. So give that a whirl for me. We're going to find our own margin of error. Even though they gave it to us, we're going to find it again. So find me your ZC. We've done the inverse norm before. I want the whole area is 1. So I'm going to share 5%. Half of 5 is 2.5%, 0.025. You can do an inverse norm of 0.025. You can go to your table and look for the 0.025. What's the ZC? Anybody? Come on, pull this up. Inverse norm. Put it in. There it is. I'm already in there. Paste. So I get a negative 1.96. What's my ZC? Positive 1.96. Good. I want the positive. Okay, so now I'm going to find my margin of error. My margin of error says, I know they give it to us, but we're finding it. ZC times standard deviation from the population, which was given to us at 7.9. N was 30. We had 30 employees here. And we're going to find your margin of error. So we take our 1.96 times 7.9 divided by the square root of 30. You can put it in your calculator just like you read it.
When you did the inverse norm on calculator, what did you put for the standard deviation?
0 and 1.
0 and 1.
Yeah, don't use any values in there. Because you want to return a z-score. So when you want a z-score returned, use the standard normal 0 and 1. So all I have to do is say 1.96 times 7.9 divided by the square root of 30. And I get this number. Now, rule of thumb. Make your margin of error the same decimals as your mean. Because you're going to add and subtract it anyway. So, rounding to the first decimal, I look to the right, I drop this, I leave this alone, so I drop this all off, and I'm at 2.8. My margin of error is 2.8. Now, I built my confidence interval. This is how easy it is. I'll do it on the calc in a minute. 28.9, we found that to be our mean, plus or minus 2.8. So you pick up your calculator, you do 28.9 is here, you subtract 2.8, you add 2.8. So this will be 26.1, and this will be 31.7. Okay, so you can write this a couple of different ways. You can give it to me as an interval, comma. You could give it to me as an inequality, there's your interval. So instead of guessing one number for your whole population for that county, you're giving yourself some wiggle room. You're saying that I can be 95% confident that the population mean of the hours worked for these grocery store people from this county will be between 26.1 and 31.7. Don't I have a better chance of getting that number than saying 28.9 on the dot? Right? Now, on your calculator, and work with me here. Go to stat, go to second. I can never get my calculator to work. Go to stat, go to test. Now, we're looking for an interval. So let's scroll down, no testing, just intervals. We found all the things that possibly say intervals, from here to here. I'm using a z-score. So which number should I use for my test? 7. It says z interval. I need this word to say interval. INT is also interval. But I don't have two samples, and this PROP, proportion, we'll get to that soon, but I don't have a proportion. I don't have a t-score, we'll get to that soon. I have a z-score. So I'm going to use number 7. Very easy to spot. So I come down here, data means I could go right to my L1. Since you put it in your L1, you could go to your L1. But that means I'm going to enter my information. So I enter my information, there's my standard deviation, here is my 28.9, N is 30, my confidence interval, enter with a decimal, you do not have to look up your ZC, your calculator does it, and you say calculate. There's my interval. Just round it to 1 decimal. So this becomes 26.1. This becomes 31.7. So you're going to get the same exact interval as this. Now the only thing your calculator, there's a couple of things it doesn't do. It doesn't find the ZC. It doesn't tell you the ZC. Internally, it did find it. It also doesn't tell you what your margin of error is. So without your formula, you're going to work yourself backwards. You're going to take your mean, because on a number line, your mean falls equal distance here. So all you got to do is go to the top number and subtract your mean. This will give you your margin of error. So even though your calculator doesn't give it to you, you can find it. Because in your intervals, your mean falls exactly in between. Has to be halfway, right? So if I subtract it from the lower or the upper, then I'll find my margin of error. The only thing that you really can't get out of this is what your ZC was. But you have a table to use also. So as you start doing more of these confidence ones, put them on your table. Are we comfortable with this? No, that's it. This is all there is to this. Very easy. All right. So let's try another one. Let's go to this one. Let's go to try it 4. This is a good one. We're going to use your calculator. We're going to take the sample data in exercise 1, and we're going to construct a 75% confidence interval, an 85% confidence interval, and a 90% confidence interval. And we're going to see what happens. So, in example 1, let me write the information. In example 1, our standard deviation was 7.9 again. Our N was 40. We surveyed 40 employees, and our sample mean was 29.6. This was from example 1. We did this yesterday. Only we cheated. We didn't put it in our L1. But you guys know how to do that. All right, so what we're going to do is take a look at how big these confidence intervals are. And I'm going to make one number line down here and write the confidence intervals as we go. So our mean is 29.6. And we're going to see what happens to this, okay? So let's start with the 75. Let's pull up our calculator. Go to Stat, go to Test, look for the one with the interval, look for the one with the z-score. So that happens to be number 7. So again, I'm going to input my data. My standard deviation 7.9, my mean 29.6. Do this with me, guys. The more times you do this, the more comfortable you will get. 40. At a 75%, make sure you use your decimal. 75. I'll do 75 by hand with you too, with an inverse norm. But let's do it this way. So calculate. So I'm going to round it to 1 decimal. I get 28 point what? To 1 decimal. To, good. To where? 31.0. Good. Okay. So I'm going to put this on here. I'm going to say it's coming out here to 28.2. And it's equal distance over here to 31.0. Okay, that's my green. I'm going to change my confidence interval. Easy. How easy is this? All I have to do now is just go in there, my calculator left me, and just change what? Confidence level. I'm going to just change this guy to 0.85. All the other information is the same. If I had to do this again by hand, I would just have to redo my ZC, find out my ZC, go to my margin of error formula, plug it in, and find it. So I'm going to come here and I'm going to calculate. So now, I'm going to put this in red. We have 27.8 to 31.4. So 27.8 is a little bit over here. And 31.4 is a little bit over here. Look at my number line. What happened as my confidence interval went up? As my confidence level goes up, what happened to my interval? It got wider. Good. So we notice this. As the confidence level goes up, write this down somewhere. The confidence interval gets wider. Good word for that, Haley. Great word for that. It's not bigger, it's wider. Bigger, and the numbers are endless, so we don't want to really say bigger or more. We want to say narrower or wider. So let's do one more. So what do you think is going to happen to the last one? To the 90. What do you think is going to happen to the 90? It's going to keep following this and get a little bit wider, right? And then we're going to take a look at why that happens. So we're going to come down here, come down again to number 7. We're going to put our data in, and it's there. All we have to do is say 0.90 and calculate. So let's put this in blue. I got 27 point, what should I round this to? 5, good. To 31 point what? Good. Take this off here. So 27.5, a little bit out here. And 31.7, a little bit out here. So as our confidence goes up, confidence interval got wider. Make sense? If I want to be more confident, shouldn't you give me a little bit more wiggle room, a little bit more room to play? I want to be 90% confident that my mean for the whole population for that county falls between those two numbers. As I need to be more confident, just give me more wiggle room. I'll make that. So I need you to remember this. As the confidence level goes up, the confidence interval gets wider. Make sense? Not so hard, right? guys to try example 5. Well, example, I want to do example 5. Let's do example 5. All right, we're going to do try 5 using this information. The only thing that's going to change is this. My sample size is going to be 30. So I want you to do this for me. I put this into here because this one's in the book, but the 30 is not. But the process is the same. So if you're going to look at the book, this way you can figure out the process, but at least you won't have to do that. So I want you guys to work this out for me. There are no probability statements here. I'm not asking you what the probability is. I'm asking you to construct a confidence interval. This is very different than what we've been doing. So I want you to take a minute. Okay. Everybody come up with an answer. Riley, what'd you get? Tell me how you did it. Tell me what you did. Okay, so let's go put it in the calc. Riley is the calc. And you went to stat, you went to test. Number 7, there it is. And you put in your information. So standard deviation, 0.5, mean, 22.9, and 30. I want you to use the 30. Calculate 90, calculate. So what did you round this to? 22.5, good. And 23.4, good. Again, your mean is 1 decimal, so make your interval 1 decimal. What did you come up with for your margin of error? So how did you find that? From here? So when you subtract it, what do you get? 0.4? 1? Is it a 0.5?
That's 0.5.
Yes. So 0.5? Good. Anybody not able to do that on their calc? All right, we're going to do this the long way. We're going to say I have a confidence interval of 90%, so I need to find my ZC. Again, this is 90, so I'm going to do inverse norm, 1 minus 0.90 divided by 2. When I do that, I find my ZC to be 1.645. If you round to 1.64, I'm okay with that. There's 2 that go 3 decimals. You don't have to do it that way. So my margin of error says take my 1.645, take my standard deviation, divided by my square root of n. So when I put this in, I get 1.645 times 1.5 divided by the square root of n. This works for me. There it goes. It's temperamental. Whoa. Okay, I did something wrong. Times. I don't think I divided. My calculator is so temperamental. God bless you. Alright, so I think you know what I'm doing here. Except my calculator doesn't want to cooperate. There it goes. Alright, so when I do this, I get 0.5. I think it works better on that side of the board, not this side of the board. And from here, I build my interval. Either way you want to do this is fine with me. So plus or minus 0.5. But I don't want you to leave it like this. I either want you to give me this, or an inequality, this. And now, to finish this, my interpretation is I want to be 90% confident that what? That my population mean age of all students enrolled will fall between 22.5 and 23.4 years of age. I want to be 90% confident that I took my sample and I inferred this about my population. Okay? Okay, tomorrow we'll finish this